Good evening, everyone. Welcome to day 5 of our 15 days free training program on Python for AI. So, before we move on to day 5, let's quickly recap what we learned till now. So, we have started learning about data types. So, the purpose of data types is to allocate sufficient memory in the space of the main memory of the computer. And these will tell us what is the type of value we are storing in our variables. So in Python programming, we have mainly 14 data types and they are classified into 6 types. So on day 2, we've learned about fundamental category data types. So these are used to store single values, and the types of fundamental category data types are int type, float type, boolean, and complex. So int type or integer type is nothing but the whole numbers or values like 10, minus 25, 0, and all. And when it comes to float data type, so the values are real constant values or the values with floating points like minus 3.14, 2.15, in that way. And Boolean is nothing but true or false values. And complex is nothing but the values which have real plus imaginary part. For example, 2 plus 3j. So this is the real part and this is the imaginary part. And till now we've learned about sequence category data types also. In that, we learned about string. And then we learned about bytes and also byte array and then range. So sequence category data types are used to store sequence of values. It also stores sequence of characters. And range is mainly used in loops. Now today we are going to learn about list category data types. So firstly, let me ask you guys something. If you want to store marks of some, let's say 5 students, so will you create all 5 separate variables like a equals to 25, b equals to 30, c equals to 40? In that way, will you create all 5 variables? So it is long. In the real time, in any school or your classrooms, there will be hundreds of students. So it is very hard to store each and every student values in each variables, right? So that is why we need to have something that will store multiple values at one place. So that brings us to list category data types. So these list category data types are used to store multiple values either of the same type or of the different type or both types, and there can also be unique values and duplicate values. So here same type means same data type, or the data type can be different also. You can store different values in it, or you can store combination of both the types, like same type values there can be there and different type of values also can be there. And it can also store unique values like distinct values. And also it can also have values which are duplicates. So duplicates nothing but the same number will occur twice or thrice or more times. Okay, so the two data types in list category data types are list and tuple. So this list category data types will maintain insertion order. So what is insertion order? As we learned yesterday, insertion order means in which order will I, so in whichever order will insert the values, in the same order it will be displayed. So that is the insertion order. So list and tuple values will follow the insertion order. So in whichever order we'll insert the values, in the same order, it will be displayed in our output also. So let's start with list first. So list is one of the predefined classes and it is treated as list category data types. So list is like a collection of items stored inside square brackets. So it is like a collection of items. And to represent list, we'll be using the square brackets. And each element should be separated with commas. Like if you have some two values, they should be separated with commas. And they are represented with square brackets. So list will store multiple values either of same data type or different data type or both types. And also it can have unique values and also duplicates. And the objects in list will maintain the insertion order. So in whichever order we'll insert the data, in the same order the elements will be displayed. So think of a list like some class attendance register. So the names are written in order and also you can update the entries. Like let's say we have some 4 students. We'll have the values in an order and you can update the entries. Like if there's any change in the name, you can change it. And also you can remove someone. If someone leaves the school, you can remove that person. And if someone joins the school, you can enter that person's name in the register, right? So that is how your list behaves. Same like your registers or grocery lists or to-do lists, our list will behave. So the key properties here are we should represent list in a square brackets and it will follow or maintain the insertion order, and then it is also mutable. So we learned about mutability and immutability, right? So mutable is nothing but we can modify the elements. Mutable is nothing but we can modify the elements in a list. And the operations which will we can perform on list are indexing, that is obtaining single value, and slicing, obtaining multiple values. Or we can obtain a group of values in your list. And then we can convert any other type of value into list type value by using the function list parenthesis. So using this, you can convert any other data type value into list value. So there are mainly two types of lists, that is empty list and non-empty list. So firstly, let's know about empty list. So empty list is nothing but it is the list in which it doesn't contain any elements. So the length of the list will be 0. And when it comes to non-empty lists, a non-empty list is the one which contains elements and the length will be obviously greater than 0. So it will contain elements, right? So there will be some length. So that is the length is greater than 0. Now let us look at some coding part. So you'll have better idea of lists. So firstly, as we know, lists are of two types, empty list and non-empty list. So you can represent empty lists using just square brackets. You can give some variable name equals to square brackets, or you can also do variable name equals to list. So these both are empty lists. When you want to represent empty lists, you can use these. And moving on, when you want to represent non-empty lists, obviously you will create some variable name Inside of that, you will have your values like 1, 2, 3. So this is the non-empty list. And then here we have the example. So firstly, we have a list L1. So that's one list. And the elements in it are 10, 20, 30, 40, 10, 20. So as we got to know, it consists of same data type elements. So these are all integer data type elements. And here we have unique values like 30 and 40. So it is only one, it occurs only one time, right? So these are unique values. And when you go to 10 and 20, so they are occurring two times. So these are duplicates. So list consists of same data type elements that can be unique or duplicates also. So now let us print this list. So what we can use is we can use print in the parenthesis L1. You can print the list name. And here I'm also trying to print the type of the list one to check which type it is. So first we need to run this and then this. So this is your list and we got the output, which is the list one, with the elements in it. And then the type of the list here is the class list. And here we can find the length of this list using length function. So length parenthesis, the variable name, the list name you can give, and it will print 6. So we have how many elements? 1, 2, 3, 4, 5, 6, right? So that is why the length of the list is 6. And also, as we got to know, list consists of different data type elements also, right? So that is why we have, so this 10, if you see, it is an int value. And if you see at this raw sum value, that is a string. So this is a string. And when it comes to 23.5, so that is a float value. And if you look at this true, this is a bool value. And here Python, it is again a string. So list contain elements of different data types also. It can contain elements of same data type and it can also contain elements of different data types. So let's print this. So firstly, we need to run this. And then we can print L2, which is this list. And I'm also printing, we can give a comma and print one more, which we need in the print function, that is type of L2. So which data type? The type of parenthesis function will tell. So here L2, we have the values 10, ROSM, 23.5, true and Python. And the type of this L2 variable is class list. So here I'm trying to print the L1 again and the type of L1, which is class list. And this L1 variable is stored in the memory here. And I can print that with ID of L1. So in this memory location, L1 is stored. So here I'm trying to give item assignment. So as we know, list is mutable, right? So you can modify any values. So as list will maintain the insertion order, so list will maintain the insertion order. That is, in whichever order we will insert the elements, in that order itself, the elements will be stored. So that is why here the elements, each element will have some indexes. Same as how we access elements or the characters in a string or other data types. In list also, we can have indexes here. So here the 10 element index is 0. So it will start with 0, the indexing, and will go on till the length minus 1 element. So that's still here. So 0, 1, 2, 3, 4, and 5. So these are the indexes. As this list will maintain the insertion order, we can have the elements with indexes. So this same order will be printed again and again when we access L1. So here we gave L1 of square brackets, that is 2. So 2 means the index here it is 30. So this 30 will be assigned 300 value. So what's happening here is the LHS value will be assigned to the RHS value will be assigned to LHS. So what is LHS here? L1 of 2. So in place of 30, it will be updated with 300. So let me print this. So first we need to run the updation and then we need to print our L1 value again. So here we have the new list. After the updation, this is the list L1. So if you see here, the memory addresses. So in the same memory address, it is updated. So if you see 4288, this is also 4288. In the same memory location, our L1 is updated. So that is why lists are mutable lists. In the same memory location, the values will be updated. So the elements in that list will be updated. So now let's try performing indexing and slicing. So lists will allow us the operations of indexing and slicing, right? So we'll try performing that. So here again, let me write the indexes. So 10, 20, 30, 40, 10, 20. So here the indexes are 0, 1, 2, 3, 4, 5. And negative indexing is it starts from right to left and it starts with -1. So -1, -2, -3, -4, -5 and -6. So here I'm trying to access the L1 of 2 value. So just now we updated it, right? So it becomes here 300. So when I try to access L1 of 2, the value is 300. So this will be printed here. The index 2 value, which is 300, will be printed. And we can also perform any other indexing also. Let's try doing a negative indexing. So print of, here my variable is L1. L1 of, let's say -3. So what is -3 here? So this is -1, -2 and -3. So 40 value is the -3 index position value. So when I try to print this, I'll be getting 40. And when I try to print L1 of 2, I'll get 300 because this is the value for the index 2, that is 300. And so on. You can also access any other elements in your list using this indexing operations. And then I can also perform slicing. So if you see, these are the indexing operations and these are the slicings. So I'm performing L1 of 2 is to 5. So here the beginning index is 2 and ending index is 5, right? So ending index will be excluded and it will print only from beginning index to end -1 indexes. So that is 5 minus 1 will be 4. So it will only print 2 to 4 elements, that is 2, 3, 4 index elements. So here 2 is this element and it will move it till 2, 3 and 4. It will print only till here as the end index will be excluded. So it will print only till end -1, that is 5 minus 1 elements. So it will print 2, 3, 4, that is 300, 40 and 10. So let's try printing that. So yeah, I'm performing the slicing operation. So we got 300, 40 and 10. In the same way, I can perform negative indexing also. Okay. So this is 2. And let me perform negative slicing once. So here print of my variable name L1 and the slicing part. So I want to slice from, let's say, -5 to -1. Okay, -5 is to, -5 is the beginning index and -1 is our ending index. So when I try to print it, so I'll get the output here. So what happens here internally is the beginning index, that is -5, and then this is the beginning index. So I want to print till the ending index -1, but it will print only till the values of end -1, right? So -5 to end -1. So end value is -1. So end -1 means -1, which is -2. So it will print from -5 to -2 elements only. So that is here -5 till -2. So this is the index, right? Before that only it will stop our values. So it will print 20, 300, 40 and 10. So that is the values we got, 20, 300, 40 and 10. So the beginning index and ending index. Ending index here. Okay. So now let's try doing with step values. So here we have a step value, positive value, right? First let me erase it and then so here we have values 10, 20, 300, 40, 10, 20. So here we have a step value. Step means it is like an interval. If you look at the previous classes also, you will get better idea. So step value means the interval which we are skipping. So step value here, it is a positive value. So as it is positive value, we will start moving from left to right. So we will consider these positive indexes only when we have a step value positive. So I'll move from left to right. And also here we don't have any beginning or ending index. So beginning index will be default and index will also be default values. So default by default in positive. So the beginning index is 0. So it will start from here. That is the starting. And ending index will also be default. That is our length of the list. So length of list here is 1. How many elements we have? 1, 2, 3, 4, 5, 6. So it will be 6. So 0 to 6. So we can write this as 0 is to 6 is to 2 basically. So that is also equal to is colon 2 also. That is both same. So here in this case it is same. So we'll start from 0. So 0 index here and 6. So our values will be from 0 to end -1, right? 6 -1. So 0 to 5 only we'll consider. So from here our range of values are 0 to 5. So by default, if I won't give any step value, step is 1. So how it will move? First it will print this. If step is 1, first it will print the value 10, which is at the index 0. And then it will print 20, and then 30, and then 40, and then 10 again, 20. But we have a step value of 2 here. So what will happen here is, so as we have a step value of 2, first our range is 0 to 5. And as we have step value of 2, first it will print the beginning index. So pointer will be at 10. So first it will print 10. Okay. And then from here it will check the second value. So as the step value is 2, from here it will check the value. So it 20 is the first value and then second here 300 is the second value. So from 10, it will check the first value 1, 2. So then it will print this value 300. It will skip our 20 value. Because our step is 2, it will go from here to 1 and 2 and it will point here. So it will print 300 next. So from 300, it will check the second element from here. So it will go 1, 2. So basically it will jump here from 300. It will check this is first value, then this is second. So here it will point. So it will point to the 10 next. Again, from 10, it will check the second element. 1, 2. Here we don't have any elements, right? So it won't print anything. So first it will print 10. And from here it will check the second element, that is 1 and 2. It will script 20 and it will print that 300. Okay. From 300 it will check again 1 and 2 and it will skip 40. It will go here and it will point to 10. So it will print 10. After this, from this 10, if you check 1, 2, we don't have any elements here. So it will stop there and it won't print anymore. So the output we'll get is, let's see the output. So we got 10 as we see and 300 and then 10 again. So that is how we'll get 10, 310. If you're confused about these step values and if you want to know about in depth, you can check our Python for AI 2026 playlist in our channel. In that, in day 1, day 2, day 3, I've neatly explained about these step values and how you can perform slicing better way. In a better way, I have explained there. So you can check that. And when it comes to L1 of hyphen minus 1. So first, let's have our values 10, 20, 300, 40, 10 and 20. So these are our list values, L1 values. Okay. So indexing will be 0, 1, 2, 3, 4, 5 and negative index will be from minus 1 to till the end. So these will be our indexing. So here we have, so the step value is minus 1. So the values are like beginning index, they didn't give, and ending index is to step right. So we got colon minus 1. So beginning index, there's nothing. So by default, we'll be considering it as 0. And ending index will be length by default, as there's no explicit value here. The length will be as ending index. So here the length of the list 1 is 6 here. So it is 6. So this will be considered. So colon minus 1 is considered like 0 is to 6 is to minus 1. So as we have the step value, negative value, we should move from right to left. So we should move from right to left as we have a negative value. If we have positive value, we move from left to right, right. So when we have a step value which is negative, we should move from right to left. And as step value is only 1, first from right to left we'll move, no? It will print 20 value. So as step value is only 1, it will check the first element from 20. So that is it will go here, 1. So this is 1. So it will print 10. So first it will print 20 and from here it will check the first element, that is here. It will move and this is the first one. So it will print 10. So from here again the first. So this is 1. So it will go here and it will print 40. And then from here the first element is 300. So it will point 300 and it will print 300. And moving on 20 and 10. In the same way it will print 20, 10. So we will get the outputs 20, 10, 40, 300, 20 and again 10. So that is we got the reverse of the string. Sorry, reverse of the elements order. So if we perform colon minus 1 and for that variable you can give it. So this will give you the reverse of that elements or a string or any other data type. So it will give the reverse of it. So let's print it. So what value I got? So I got 20, 10, 40, 300, 20, 10. So that is the value we predicted. So it will give the values from backward to forward with a step value of 1. So from 20, then 10, 40, 300, 20 and 10 again. So let's say we have a step value of minus 2, let's say. So in place of minus 1, let me clear it. So here let's say we have a value -2. So L1 is our list, and for that I'm performing slicing. Beginning and ending index, I want it to be default, and -2. Let that be our value. So what happens here is, first we have values 10, 20, 300, 40, 10, 20. So now step value is negative, and the step value is equals to 2. So first, negative means we'll move from right to left. So that is backward to forward we'll be moving. Negative means. So as it is -2, that step value is 2, right? So first it will point to this 20, the first ending value. So then from here it will check the second element, that is 1, 2. So this is how it will move, and it will point to 40. So it will print 40. First it will print the ending value 20. It will start from there, and it will move from right to left. So from 20, 1, 2. This is 40. So it will print 40. And from 40, it will check the second element from in this order, in this direction. So from 40, it will move 1, 2. So this is 1, 2. So it will go to 20 now. So we'll print 20. From here, it will check the second element here. 1, 2. There is no more elements, right? So it will script this 10. So basically here 10, 300 and 10 are skipped. And we got the values 20, 40, 20 with a step value of 2, that is -2. We are moving from right to left with a step value of 2. So when I try to print the element, so we got 20, 40, 20. So this is how the slicing operations will work. And then moving on. So we can create an empty list using just the square brackets. So if you see, the L3 value here is equal to the square brackets. When I try to print this, so here we are printing L3 and the type of L3. So let me print it. So as you can see here, the output we got is square brackets and the class is list. When I want to print length of L3, I need to use the length function len. So this will give us the length of the variable. And here the type function will give the data type. So what data type it is stored with. So here it is an empty list. So with square brackets, I've created an empty list. So the empty list is printed. The data type of this empty list is class list. And then the length of L3 is 0. As we don't have any elements in it, the value is 0. Okay, then we can also create empty list using this list function. So list of, so this is also an empty list syntax. Okay. So here I'm printing L4 and I'm finding the data type of L4 and also the length of L4. So I can print with explicitly with print as well. If I try to get the output, so L4 equals to list, and the output we got for L4 is the empty list, and the class is list, that is the data type. And then L4 length is 0. As it is an empty list, the length will be 0. Now, moving on to the predefined functions in list. So, there are some functions which we can perform on a list data type. So, firstly, we have append here. So, what append does is, it is used to add elements at the end of the existing list. So, what it does is, if we have some list, let's say 10, 20, 30. I want to add some 40 to it. So we can use dot append parenthesis, which value we can we want to like append or add it. We can give 40. So if your variable name is L1, so how we can use is L1 dot append parenthesis. So the parenthesis is needed. So I want to add element which is 40. So what happens is this 40 will be added at the end of the existing elements in the list. So it will be added here. So if we print this, we will get the output 10, comma 20, comma 30, comma 40. So in this way, our output will be. Okay. So let's try printing. So here I'm creating an empty list first. Okay. So this is an empty list L1. And the type of empty list, obviously it is a list, and it is stored in this memory location 2746911080960. We don't need to remember this, just for knowing we've done this. So using the id function, I can get the memory address of my variable L1. So what I'm doing here is I'm trying to append 10. So there are no elements till now in our list function. Sorry, list L1, right? So I'm trying to append a value 10. So what happens is when I try to append this value in our empty list, the 10 will be added. As there are no elements, first 10 will be added here with this append function. So let's just run it. If I print my L1, so 10 is added to my empty list L1. Now I'm trying to append a string called as ROSM. So what happens to this string? It will be added at the end of the existing elements in a list. So existing elements are 10, right? So it will be added at the end of the existing elements, that is here. So ROSM will be added here. So this is my list now. After doing this append, ROSM will be added at the end of the existing elements in our list L1. And then I'm trying to append a float value of 23.5. So what happens? This value will be added at the end of the existing elements of list. So using append, I can add this here. So if I do that, the value will be added at the end of the list. Okay, so after performing these two, ROSM and 23.45 will be added. So let's run it and we'll get a better idea. So I've run ROSM. If I try to print, you can see after just adding or appending the ROSM, we can see the ROSM in after 10. And then we can append a float value that is 23.45. So after appending 23.45, it will be added at the end of the list. So now we have a list 10, ROSM 23.5. So next example here, we have a list. So the list is, we have all string values here. We tried with int values and other string and float, right? So this list consists of only string values, that is apple, banana and kiwi. Okay, so this is the list and I'm trying to append a value that is, so here we have a list apple, banana, kiwi. So that is of a list data type and this is the memory address it is stored at. So now I'm trying to append sberry or strawberry. In short form, I have written sberry. So let's say I'll just write the whole name. So, okay. So I've appended this strawberry in my append in L2. So what happens here is first I've appended sberry, right? So that is added after kiwi. So after kiwi, that is here, the end of the list is there. So there it added sberry first and then I tried to append strawberry also. So it added that as well. So in this way, using append function, you can add elements. So what append does is, append function will add elements at the end of existing elements in list. So if you want to add any elements to your list, you can use this append function. Then moving on, we have the second function. So it is an insert function. Okay. So this insert function, this is used for inserting elements at a specific index position. So as we know, when we have a list, let's say 20, 30. So when we have some elements in a list, they have some indexes, right? Starting from 0, it will go till end, like the length minus 1 value. So here length is 3, as we have 3 elements, 1, 2, 3, length is 3. So the indexes will start from 0 till length minus 1, that is 3 minus 1, 2. So 0, 1, 2 are the indexes here. So I want to insert, not just using append, I can insert at the end, right? But I want to insert some element after 10 or after 20 I want to insert. Let's say I want to insert after 10. So what should I do? I can use this insert function and I can have, so the syntax of insert function is the variable name, let's say L1, the same L1 I'm using here, dot insert at which position I want to insert. So if I want to insert between 10 and 20, let's say here I want to insert. So after 0, the index will be 1, right? Initially 20 is that the index position 1, but I want to insert element at this position. So after 0, the element index will be 1. So at index 1, I want to append. So I should give the value of index first, comma, what I want to append, I should give. So I want to append, let's say 40. Okay. So this is the index value, comma, the value I want to append. Let's just try with this example first. So we have L1 equals to our elements 10, comma, 20, comma, 30. So let me print these. So print of L1 is equals to, so my L1 value is 10, 20, 30. Now I want to insert a value 40 at the position of index 1. So I need to perform L1 dot, so the variable name dot insert function. So insert parenthesis. Inside of that parenthesis, I need to give index first. So at one position, I want to insert. I want to insert a value 40. So I'll give 40. So now it is inserted. Again, I want to print L1. So I need to see what elements are right now, right? So I'll print it. So as you can see here at the position 1. So this is 0 position, 1, 2, 3. So at the position 1, my value 40 is inserted here with this code. At the position 1, 40 values inserted, and this is the updated L1 right now. So that is what I printed, and the values are 10, 40, 20 and 30. So in this way you can use the insert function, and then here we have a list of string values again. So here we have a values of apple, banana, kiwi. So in this I want to insert a value guava at the position 1. So position 1 means after 0 will be the position 1, right? So here guava will be inserted at this position. So apple is at 0, banana index is 1, kiwi index is 2. So after 0, that will be 1, right? So guava I want to insert here. So if I do that, so our L2 value is apple, banana and kiwi right now. And the data type is list only. So with the help of insert function, I am inserting guava at the index position 1. So let me run this. And I printed it. So as you can see, guava is inserted at the position 1. So after apple, which is the index 0. So here apple is index 0. And guava at the position 1. And banana is at position 2. And kiwi is at the position 3. Okay. So here I got to insert my new string. And then now again I want to insert watermelon. So I want to insert watermelon string at the position 1. So position 1 means what? After 0, that will be the position 1. That is here between apple and guava. So here I want to insert element, new element again. So I'm giving the index 1 and the value I want to insert is watermelon. So using the insert function, I am performing this operation. So when I run this, so here as you can see, watermelon is inserted at the position 1. So we have apple that is at the position 0 and watermelon at the position 1, guava at the position 2, banana at 3 and kiwi at 4. So watermelon has been inserted at the position 1 using insert function. So this way you can use insert if you want to insert elements at the exact location or the index you want. Next, we have the function remove. So this function is used for removing the first occurrence of a specified element. So if the specified element is not present in your list, then we'll get some value error. So basically remove is used to this is used to remove the exact element you want to remove. So till now we've accessed elements with indexes, right? So this is a function in which we can directly give the element we want to remove. So the syntax is the variable name or the list object name. So the list one, let's say list one dot remove and which element I want to remove exactly, that value I should be giving inside of this parenthesis. So we have a list L2 that has values apple, banana, kiwi and guava. So here, let me run this first. So these values and this list is assigned to the variable L2 here. And when I'll print this, we'll get the value of list. So apple, banana, kiwi, guava are in our list L2. Now I want to remove this exact banana value I want to remove. So this string which consists of the value banana, I want to remove this. So what can I do? I can give the list name dot remove function and inside of this I can specify my element name. So I want to remove banana, so I give banana here. So when I try to run this and print my list L2, so as you can see here, so there is no banana anymore. So it is removed. When I know the exact element which I want to remove, I can use the remove function to remove that exact specified element. Okay. And here, see, I am trying to remove something called as kiwi. But here it says value error list dot remove x is not in list. So x means this value is not in list, it is saying. So why do you think it is saying that way? So that is because here if you see, it is all in small letters. If you see here in our L2 list, we have K capital IWI. So this. So as you know, Python is case sensitive, right? Python is case sensitive. That means case, we have uppercase, lowercase, mixed case letters, right? So uppercase means all capital letters and lowercase means all small letters. So here we have the first letter as capital, so that's kind of a mixed case. So this value and this value are the element. So even if the spelling is same as the cases are different. So this is all in lower case. And here if you see K is in capital letter and other all are lowercase. So as Python is case sensitive, it will consider both of these elements as different elements only. Only if I give capital K, small w, small I, and if I try to remove that, in that case only it will remove this function. Sorry, this is the value. So only if the case is matching, it will remove that value. If I give all small letters like this, So this will be considered as a different value and that will not be removed from your list. So that is why I'm getting the error of value error, because when your specified element is not present in the list object, we'll get value error. So as the all lowercase letters of kiwi is not present in your list, so that is why we got value error. And now I'm trying to remove some value, that is 100, from my list L2. So this 100, if you see, is it present in this list L2? No, right? It is not present. So that is why we'll get a value error. When the specified element is not present in our list L2, we'll get a value error, that is X is not in the list. And moving on, we have a list that is 10, 20, 30, 10, 20, 40. So here we have some duplicate values, if you can see. So we have 10 two times and 20 two times. So 30 and 40 are only the unique values here. So if I try to print this first, so we have all the elements, including the distinct elements, that is unique elements and duplicate elements. So I'm trying to remove the 10. So what happens is with 10, it will remove the first occurrence. So when there are duplicates, what remove function does is, when I specify the element, it will remove the first occurrence in the list. So as you can see here, this 10 is occurring for the first time. Then here, this 10 is the second occurrence, right? So this is second occurrence and this is the first occurrence. So it will start checking for the element, and first when it will get to have that element, that is the first occurrence, it will remove that first occurrence. So it removed this 10. So that is why we have values 20, 30, 10, 20, 40. So as you can see, the first 10 here, which we have here, that is removed. And now I'll try to remove the 20. Okay. So this is our existing list right now. So if I remove 20 and print my list, so as you can see, this 20 is removed. So we have 220 values here. So this is first time it is occurring and this is the second time. Or if you want to see in the updated list, here it is occurring for the first time and second time. So I've used remove of 20. So that is why it removed the first occurrence of 20 and it gave me the remaining elements in the same order, that is 30, 40, 20 and 40. 30, 10, 20, 40. So that is the list I got here. So what remove does is, it will remove the first occurrence of the specified element. So in this way, you can use the remove function. Moving on to the pop function. So pop. You can use pop when you want to remove the element based on the valid existing index. So using remove, when you know the exact value you want to remove, you can use remove. Or the element you can use remove. But if you don't know the element which you want to remove, and if you know the index position, so I want to remove the value at index, let's say 2 or 3. So you can use pop in that case. So how you can use pop is, so the list name, let's say list1 dot pop, and inside of this parenthesis, I can use the index. If I give 2, it will pop the element at the position 2 in that specific list. So this index can be positive index or negative index also. But if the index is invalid or out of range, we'll get some index error. So here the index should be within the range, that is from 0 to length minus 1 of that list. So let's try doing some code. So we have a list called as apple, banana, kiwi, guava, banana. So we have elements in a string format, and here the indexes of these are, so 0, 1, 2, 3, 4. It will start with 0 and it will go on till the end of the list elements. And when you want negative indexing, I can use -1. So from right to left, I'll do that. -1, -2, -3, -4, and -5. Okay. So in this way, the indexing is done for this list elements. And if I try to run this, so this list of elements is assigned to my L2 right now. And if I print that, I'll be getting the list of elements: apple, banana, kiwi, guava, and banana again. So now I want to pop an element at the index position 4. So which position is 4? So here you can see this is the positive index 4. And in this position we have banana. So what it does is it will pop this banana value. Now I'll run this. So pop function will show which value it is removing or popping. So it gave the value which it removed, that is banana. And if I try to run or like print my L2 value again, if you see here, this is the updated list. That is apple, banana, kiwi, and guava. So this value here at the fourth index, that is removed. Due to the pop of 4, this value is removed. Now I'm trying to pop the value 1. So the index position is 1. So at index 1, what is the value? If you see here at the index 1, so we have one more banana and this value will be popped. So I'll run this and the popped value is banana. And if I try to print my list L2, I'll get the values apple, kiwi, and guava. So these are the remaining values: apple, kiwi, and guava. Now I'm trying to pop a value 11. So index is 11 here. But do we have the index 11 here? Only we can see 3 values right now. After popping these 2 values, I have 3 values. So 0, 1, 2. So there is no 11 index. So it is very out of range, right? So that is out of range index. So we'll get a index error here. As our index is very out of range and invalid here, so we'll get an index error. Let me print that. So the value, it is index error value. So pop index out of range. So as our index is out of range, so that value cannot be popped. So that is why we'll get index error. So here I'm trying to pop the value at the index position 10 from an empty list. But in an empty list, do we have elements? No, right? We don't have elements. So in an empty list, there are no elements here to pop also. But what I'm doing empty list dot pop, the index is 10. So this cannot be performed as we don't have any elements. There are no values at the position 10. So we will get an error. So index error, pop from empty list is the error here. So as there are no elements in your empty list, we cannot pop the element at the position 10 or the index 10. So that is why we got index error. So if you see here, so now what we have, the values we have at L2, list L2 is, let me write it. L2 values are apple, kiwi, and guava. So these are the existing values right now in L2. So what are the indexes of this? 0, 1, 2, -1, -2, and -3, right? So here we are popping the negative index, that is 1, -1. So -1 means it will pop the value guava. So let me run it. So it popped the value guava and the remaining list would be apple and kiwi only. As we popped guava at the position -1 index, so we'll have the remaining values as apple and kiwi. And here now, what are the values in L2? So guava is removed, right? So here there are no more values. and the indexing will change. So this is the only elements we have 0, 1, and negative indexing would be -1 and -2. So here I'm trying to pop the value at the position -2 or index -2. So -2 means we have it here. So index -2 is apple. So this apple will be popped out. So as you can see, when I performed this action or executed it, apple is popped out. And remaining elements in my list L2 is just kiwi. There are no more elements after popping the value apple also. So just we have the value kiwi in my list L2 right now. Okay. So now, so here I'm trying to pop. So as you can see, we can create an empty list using the list function, right? So list of means this is a empty list. And I'm trying to pop the element at the position index 1. But as this is an empty list, there won't be any elements, right? So there is no element at the index position 1. So that is why we'll get the index error here. We cannot pop elements from an empty list because there are no elements to pop. So we gave index 1 here to pop. So we'll get an index error. So index error is, I'll try to run this first, and index error is pop from empty list. So that is why we'll get an error. We cannot pop elements from empty lists. So till now we learned about how we can pop a value at some index, right? So we can also use this pop function without any index value. Just we can use this pop without giving any index. And what this function does is it will remove the last positive indexed value. So how you can use this is you can give a list value, let's say L1, and you can just use pop. So we'll not write any index here, just we are popping the last element. When we want to pop the last element, you can use dot pop parenthesis. So here we have a list L2 and we have the values apple, banana, kiwi, guava and banana. Okay, so these are the elements we have in L2. So what will happen here is when I try to pop, just pop. So it will remove the last positive indexed value. So here the last value with a positive index is banana, right? So it will pop banana. Let me just run the code. So first our list consists of apple, banana, kiwi, guava and banana. So when I try to print it, so this is my list and now I'm popping without any index. I'm just using the pop function. So this will pop the last value which is banana. So this is popped. When I try to print my list again, so we have only these values now. Apple, banana, kiwi and guava. So this value banana is popped. So due to this banana is popped. So we have only values from apple, banana, kiwi and guava. Okay. So these are the values in L2 right now. Now here what I'm performing, I am inserting. So I'm using the insert function here to insert new elements and pop them. Okay. So at the position 1, I am inserting strawberry or raspberry. So position 1 means here, right? So here, or if you want to know about it in the updated list, so here the value of raspberry will be inserted. So let's perform that. So I'm inserting a value raspberry at the position 1. If you can see here, the new value is inserted after apple. And the new value is apple, raspberry, banana, kiwi and guava. Now I'm again trying to pop it. So pop will do what? It will remove the last element. So it removes the last element. And this is the L2 right now. So last element is guava, right? So it will pop the guava value. And that will be removed from the list L2. So now let's run. So the popped value is guava and the remaining elements are apple, raspberry, banana and kiwi. As you can see, this guava is popped. So that is why we only have 4 elements left in our list L2. And here I'm trying to perform pop on an empty list. So this is an empty list. So this doesn't have any elements. So no elements. And when I try to pop it, so what pop does, it will remove the last element in your pop, like the list value, right? So there are no elements in this list. So it is an empty list. So what happens here is we will get an index error again. So when you try to pop from an empty list, we'll get an index error. So this is the same. So list parenthesis is used to represent an empty value, like the empty list. So these both are empty lists only. And when I try to pop element from that, I'll get an index error. That is pop from empty list. So as there are no elements to pop in these empty lists, we'll get an error of index error. So moving on. Now we have a function called as clear. So this clear function is used to remove all elements in your list object. Rather than removing just one element using remove or pop functions, we can just use clear function to remove all the elements in your list object. So how you can use this is, you can give your list name, list object name, and you can use dot clear parenthesis. So it will just remove all the elements in your list object. So let me just run it. So I have a list of apple, banana, kiwi, guava and banana. So that is my L2. And this is the current list. So if you see the length of the list, so you can find the length of this any list or string using len parenthesis, and inside of that you need to put the variable name. So the length of list L2 is 5, as we have how many elements? 1, 1, 2, 3, 4, 5. So 5 elements, right? So that is why length is equals to 5. So now I'll try performing dot clear. So what dot clear does is, it will remove all the elements from your list. So if you see here, there are no more elements in your list. So this is what clear performs. So it will remove all the elements in your list object. And if I try to get the length now, so as you can see, it is a 0 now. So there are no more elements in your list L2. So that is why we got length equal to 0. So when you try to perform clear operation on empty lists, no error will be there. Just it will execute and it will be done. So if you see here, we have just square brackets and then we have list. So these both are empty lists, right? To represent empty list, we can use this. So when I try to do draw dot clear for this empty list, so what happens is, as you can see here, we are not getting any error. Just it will execute and it will be done. Will not get any error. Like we got in pop, index error or value error, will not get any errors. Just they'll execute and they'll be done. Next, moving on. So there is something called as del. So this del here, del keyword. So it is used to delete elements based on indexing or slicing, or you can just delete the entire object. So you can delete a value using index or slicing, or you can just remove the entire object also using this del statement. So the syntax of this is del space, you should give the space and then the list object name, and you can give the index. So in this way I can use the del. So this is the syntax. So like pop function, so when it pops a value, it will give the value in the output, right? So the return value. So this del will not return the popped or removed value. So it will raise index error if your index is out of range. So when your index here, it is out of range, you will get the index error value, like the error warning. So let me just try doing it. So this is my list. That is apple, banana, kiwi, guava, and banana again. So this is my list. So I'll run it. So this value is assigned to L2 now. So if you look at the indexing in this, so apple is at 0 position, 1, 2, 3, 4, right? So these are the positions. So as I'm trying to delete L2 of 1. So 1 means the position is banana here. So banana will be deleted from this. So let me run it. So del of space L2 of 1. So that will delete banana and remaining elements are printed when I print L2. So this is modified. L2 is modified into apple, kiwi, guava and banana, the remaining elements. Here I'm trying to perform slicing. So now the elements I have are apple, kiwi, guava and banana, right? So the indexing also will change, right? As we removed one element, indexes also will change. So indexes are 0, 1, 2, 3. Negative indexing is -1, -2, -3 and -4. So let me try. Here we are doing a slicing operation. What slicing does is it will give the elements from the range we want. So beginning index is 1 and ending index is 3. So it will give elements from 1 to 3 minus 1, that is 1 to 2. So 1 to 2 means the values are from 1 to 2. So it will give only the values of kiwi and guava. Sorry, it will delete the values of kiwi and guava. As we gave a delete function, we are slicing it and it will delete this part. So as you can see, the output is apple and banana. So using slicing also, I can delete the values at once. So this range values are deleted. So 1 is to 3 means the range is from 1 to 2. That is kiwi and guava. So this total values are deleted. And it will give the remaining values, that is apple and banana. So that is what you got, apple and banana. Now I'm trying. So we'll take a fresh L2. That is list 2. So now list 2 is apple, banana, kiwi, guava and banana again. So this is a new list. So we are taking it and then we are performing one more kind of slicing. So I can use this. Just let me write it. First, the values. The indexes are 0, 1, 2, 3, 4 and negative indexing is -1, -2, -3, -4 and -5, right? So what I'm doing here, I'm deleting this part, that is L2 of colon 2. So here the beginning value, there is no beginning value. So by default we'll consider it as 0, that is the starting index, and ending value, there is no value here. So we'll consider it as the length, that is the length is 1, 2, 3, 4, 5. So 5 is our length. And we have a step value of 2, right? So the range, first the step value is positive value, right? So you'll move from left to right. And the range value here is from starting, it will go till 5 minus 1, that is 4. So it will move till here. So starting to ending, it is our range. And step value is 2. So we need to consider this as our interval. And we should, as it is positive, first it will move from left to right. And then we'll check the range, starting and stopping index or beginning or ending index. That is 0 is to 5. So 0 to till the end of the values we will take. And so here, the main part, the step value is 2, right? So first, what happens is, Yeah. First, it will point to apple value, right? So when you're starting your range, first it will point at apple. And this apple, as you know, this will be first, it will point to this. And then first we'll forget about deleting. First, we'll know what our L2 of colon 2 represents. So first it will point to apple. And then from here, it will check the second element, that is 1, 2. So it will point to kiwi now. First it is apple, and then 1, 2, it will point to kiwi. Okay? And from here, kiwi, it will check the second element, that is 1, 2. So this 1, 2. So banana, it will represent banana. So our L2 of colon 2 will represent the values apple, kiwi, and banana. So there are no more values, and your range will end here, right? So what happens is I have given del in before this, I have given del statement. So what it does is it will delete these values. That is apple will be deleted, kiwi will be deleted, and banana will be deleted. So we are deleting these values which represented by L2 is to colon 2. So apple, kiwi, banana will be deleted, and we'll get the remaining part, that is banana and guava. So when I try to print the L2, so I got, as you can see, banana and guava. So I have deleted these values using slicing. And then moving on, here what I'm doing is I can delete the entire object also, right? So using del, I can also clear the entire object. So what we did here is del space L2. So totally this list object is only deleted, not the values. Totally the list object itself is deleted from the memory. So when I print this, so del L2 is performed, and here print L2. So as the total list object is only deleted, so L2 is not defined till now, right? So we'll get a name error of L2 is not defined. The L2 is removed entirely from the memory location. So we cannot access L2 anymore. Now let's see. We are creating a fresh L2 list. That is apple, banana, kiwi, guava, and banana. So what happens here is I'm printing it. Yeah, first I should run this. Then these values will be assigned to L2, and I'll print L2. So L2 is apple, banana, kiwi, guava, and banana. So if you see here, instead of like deleting the entire object, I'm just deleting the values. So I'm accessing the values using the slicing operation, right? So here I'm only accessing the elements of list, not the total list. Like here, I'm accessing elements of list using the slicing operation, and I'm deleting only these elements. So here if you see, we have colon. So the beginning index is to ending index is to step value. So all are default values here, as I have not explicitly mentioned the values, all are default values. So 0 is to the ending value would be the length, that is 5, is to step value by default it is 1. So these are all the default values. So if you see 0. So 1, 2, 3, 4, 5. So 0 to 5, that is here. So as your step value is positive, we'll move from left to right. And step value is 1. So first it will point to apple, and then to banana. And then from banana, it will check the first element, that is kiwi. And then from kiwi, it will check the first element, that is guava. And from guava, it is banana. So it will move from apple, banana, kiwi, guava, and banana. So to access all elements in your list, you can just give the slicing operation of either just a colon, or you can give two colons. When you have step value also, you can give this way. So this represents all elements. So I'm deleting all elements from my list L2 using this function. So when I perform this, as you can see, initially it has all elements neatly. But now there are no more elements here. So what is the difference between these both here is, here the entire object is deleted. Like the L2 is totally erased from the memory location. But if you see here, just the elements of L2 are deleted, but not totally the L2. The object still is there, like here in the memory location, L2 is still there, but all elements inside of that L2 are deleted. So now moving on to the next function, that is index. So this index function is used to find the index of the specified element. So if the element doesn't exist, we'll get a value error. So basically index function is used to get the index of the specified element. Okay. So the list object, how we can write this, the syntax is the list object dot index, and for which element I want to get the index, that element I should give in the parenthesis. Okay. So this is the syntax of index function. So here we have an index, a new index, sorry, we have a list L1 and it consists of elements 10, 20, 30, 40, and then Python, Java, DS, and also Boolean value true. So what happens here is, first I'll run this and these values are assigned to L1. So this list of values are assigned to L1 and I'll print it. So L1 consists of all these values 10, 20, 30, 40, Python, Java, DS, true. So that list it consists. So now I want to find the index of the word or string Python. So what I can do, I can give the variable name of that list, that is L1 dot index function, and I can give inside of the index function, I'll give the value or the element whose index I want to find. So I gave the element Python. So what is the index of Python? So let's just do the indexing ourselves. So it will start from 0 till the end, it will go until end minus 1. So the length minus 1, 0, 1, 2, 3, 4, 5, 6, 7. Okay, so these are the indexes. So what is the index of Python here? It is 4. So we should get the output 4. So let me run this. So as you can see here, we got the output 4. So that is the index of the word or the string Python. And then we have one more list, that is L2 equals to 10, 20, 10 and Java 45.6. So here I want to find the index of 10. So first we'll assign these list values to L2. So these are the values in our L2 list object. So now if I want the index of 10, so what happens is here, let's just write the indexes 0, 1, 2, 3, 4, right? So what our index function does is it will give the first occurrences index. So here we have two tens, right? So it is repeating like the duplicate values you have. But if you see here, we got 0 only. So 0 means the first 10 occurrence, the first occurrences index it is giving. So that is 0. So index will give the index of the first occurrence of your element, the specified element which you want to find the index of. It will give the index of first occurrence of that specified element. So when I try doing index of 10, it gave me the first occurrence index, that is 0. So that is how I got 0. Here, if I try to find the index of 100, but 100 is not present in our list L2, right? So as 100 is not present in our list and I try to find the index of 100 in our list L2, so I got a value error, that is 100 is not in list. So as this is not present in the list, I got a value error. And then moving on, we have a function called as count. Okay, so the count will give the number of occurrences of your specified element. So how many times it is there, the value, it will give the number as the count. So we'll just count the money or pencils or coins, right? So when we are counting, we'll go 1, 2, 3, 4. So what it does is it will count. Here we have so many tens. So it will count 1, 10, 2, 3, and 4. So we have 4 tens. And then moving on to 20, we also have duplicate 20s here. First, let me assign that value to list. And we have many 20s. Like here we have a first 20, second, third. And moving on, I have two 30s here also. So 1, 2, two 30s. And 40, 50, 60, we have only one occurrence of that elements. So if you try to get it, so how we can get this is list object dot count of the element I want to count. That is 10 here. So L1, that is the list name, dot count of 10. So count of 10 is 4 as we counted 1. Just a second. 1, 2, 3, 4. So that is why the count of 10 would be 4. So this is the count of 10. And I want to count 20. Okay. So 20 here is 20 occurs 3 times. 1, 2, 3. So that is why the count of 20 is 3. And 30 will be count 1, 2. So 2 and 40 only once. And 50 also once, 60 also once. So when I try to print that, so L1 dot count 30 is 2 as it occurs 2 times. So the count is 2, and as 40 occurs only one time, the count is 1. And if I try to find the count of an element which is not present in our list, will not get any error. What it does is it will give just the length is equals to 0. Okay, so if the element is not present in the list we are trying to find, and the length will be given, or the count, sorry, the count will be given as 0 as it occurs 0 number of times. And also I'm trying to find some string value NEUT in my list L1. So as this is also not present in my list L1, the value or the count here is 0. And then I have a function called as extend. So we have 3 more functions. So please be patient. We'll be done with that. So we have a function called as extend. So what extend does is when you want to add to lists. So here I can perform extend function using the syntax of the list one dot extend dot parenthesis list 2. So what this will does is it will add the elements of list L2 to the list L1 and it will be extended in that way. So if you see here, we have a list 10 ROSM Python in L1. And list L2 is data science or DS, Django and pandas. Okay. So first I'll assign them and I'll print them. So list L1 is 10 ROSM Python and list L2 is DS, Django and pandas. So here I'm trying to extend L1 dot extend L2. So I'm adding the values of L2 to L1. So if I print this, as you can see here, L1 is updated with the values of L2. So initially it had only 3 values L1 and L2 also it has only 3 values in there initially. So when I performed L1 dot extend of L2, L2 values are added to L1. So that is why it is also added in an order. Okay. So first we have 10, then ROSM, then Python. And then the L2 values are DS, Django, Pandas. So they are added to L1. In that same order, it is added at the end of L1 elements. So DS, Django and Pandas are added. But we didn't extend any L2, right? So L2 values will be same only. Only L1 values will be updated with values of L2. So that is why L2 is still DS, Django and Pandas. But L1 values are updated with by adding the values of L2, it is updated. And then moving on, we have three list values here. So we have list 1, 10 raws and Python. And then we have a list 2, DS, Django, Pandas. And then we have list 3. In that, we have 3 strings, Ram, Lakshman, and one more man. Okay. So by this, I have assigned these list values to L1, L2, and L3. So if I print those values, so these are my values. In L1, we have 3 values, 3 strings, and L2 list, we have 3 strings, and L3 list also 3 strings. But our extend function will only take a single argument. So when you want to extend, you can only give dot extend. Only one value you can give, like L1 or L2 or L3 only. You cannot just give like L1 or L2 comma L3 here. As you can see here, we have given 2. So we are trying to add 2 lists into L1 at the same time. So that is not possible with your extend function. So it will give a type error, that is list extend takes only one argument, but 2 are given. So L2 and L1 are given, but only it takes one argument. So that is the error here. So if you want to extend 2 elements at once, like if you want to add elements of L2 and L3 to L1 at once, what you can do is, instead of doing like this, you can just use an addition operator and you can do L1 plus L2 plus L3. So in this way, you can just do the operation and the L2 elements and L3 elements will be added to L1. And what here I'm doing is I'm adding L1 elements plus L2 elements plus L3 elements and I'm assigning these values to L1 again. So L1 only will be modified with the values of L1, L2 and L3. So the RHS will be assigned to LHS. So that is why L1 will be updated. And L1 now consists of all the values from L1, L2, L3. This way I can extend by adding multiple lists to single list instead of using this way, because this is not possible. And then we have a function called as reverse. Okay, so this reverse is used to obtain the reverse of list object content. That is like from back to front, if you want the reversal of some list object. Let's say we have a list called as 10, 20, 30. So I want reverse of this. So reverse means what? From right to left will move. That is 30, 20 and 10. Okay. So I want the reverse objects. So what I can do is I can just perform list dot reverse function. So I have a fresh list here, L1, which consists of number of elements with duplicates and unique values also. So my list 1 consists of these elements. And now I am performing L1 dot reverse of parenthesis. So I'll get the elements from backward to forward or right to left. One by one, we'll get from right to left or back to front. So it will be reversed. And the values, as you can see, so first, at the last, we have 60. So 60 is printed. And then 50, then 50, 40, 30, 10, 40, 30, 10. In that way, the elements will be printed from backward to forward. So in that way, you can get the reverse of that list object. So we have a fresh list L2 here. So L2. In L2, we have integer value, string values, boolean value, complex value, and float value. So a list can consist of different data type values, right? So that way you can have L2. And if I print L2, so these values are stored in L2. So when I perform L2 dot reverse of parenthesis, like reverse of function, when I'll do this, so all the elements of L2 are reversed. So when I print it, sorry. So when I print it, if you see here, the value 23.45 So that is the last value, right? So we are moving from back to front. So 23 first it will be printed. And then we have the complex value 2 plus 3j and true and Python ROSM 10. So in this way we can reverse any elements in a list object. Then moving on. So the final function in list data type is the sort function. So this function is used to sort the similar type of data in the list object, either in ascending order or descending order. So by default, so in the sort function, there's a parameter called as reverse, okay? So by default, the reverse is false. So that is why just when you use sort function, it will give you the ascending order. So when you use sort function without like, if you see here, just I've used sort function, it will give me ascending order. It will give ascending order because the reverse function or the reverse parameter here is false. Inside of this sort, we have a parameter called as reverse and that is by default false. So that is why we'll get ascending order. So let's perform it. So I have some values, negative values, zero value and positive values in a list L1. So these are the values of my list L1. Now I'm trying to sort that value. So L1 dot sort parenthesis. So this will sort my list object elements into ascending order. So ascending order means first I'll get the negative values and then 0 and then positive values in an ascending order, right? So let me print it. So as you can see, minus 5, minus 2, 0, 7, 10, 15 till 56. So this is the ascending order of my list 1 or L1. So now I want, let's say descending order I want. So what I can do? So this is in ascending order already, right? So this is the ascending order. Now I want the elements in descending order. So what I can do? I can just print them from right to left, right? So to print elements from back to front or right to left, I can just use reverse function, which we just learned, right? So I can perform reverse function on L1. So L1 dot reverse. So this will produce the reversal of the ascending order, which is the descending order. So it will give from 56 to minus 5. So 56, 34, 23 until minus 5. So in this way, you can get the descending order of elements. So this is a two-step process to get the descending order elements. But if you want to find them in just one step, you can just use the sort function. But you can use reverse equals to true. So by default, reverse equals to false. So to get a descending order, first you'll do sort. You'll sort that values into ascending order and you'll get a reverse of that ascending order. So that is descending order, right? So directly to do it, you can just give reverse parameter equals to true. So that will find it will sort your elements into descending order directly. Instead of performing sort and then reverse, you can just get it in this way. So first, the list is a jumbled list of negative elements, 0 and positive elements. So now I'm performing the L1. So L1 consists of all kinds of jumbled elements, that is integer values. So I'm performing list of, so list of sort. This will sort elements like first in ascending order, and as it is reverse equals to true, it will reverse that element. So you'll end up getting descending order at the end. So to get the descending order, you can perform order of reverse equals to true. So that way you can get the descending order. So now I'm performing sort reverse equal to true. Now, as you can see directly, I got the values in descending order. Before I had to do two steps. So first sort in ascending order and then reverse of that is descending order. So I can perform reverse function there. But if I want directly in a single step, I can use sort of reverse equals to true. In that way, I can get the descending order of all the elements in your list. Okay, then we have a list of strings. So I have kiwi, apple, guava, raspberry, that is strawberry, and banana. So this is a list L2 here. So if I print it, these are my values. So now I want to sort these values into ascending order first. So I can just use sort element, sort function. So sort only works for similar data type elements. If there are int values and string values in the same list object, that won't work because you can't compare it, right? So to compare it, you need the same data type, like all string values or all integer values. So that is why first L2 consists of string values here, and I'm trying to sort it first into ascending order. So here if you see first A. So based on the alphabetical order, it will print. So first A is the first element in our alphabets, right? So A and then B and then using G here, guava is printed and then K and S. So these are printed in alphabetical order. So that's the ascending order here. If I want the reversal of that string, so I'll get the descending order in from raspberry, kiwi, guava, and then banana. If I want directly the descending order, I can just perform sort of reverse equals to true. So the reverse parameter is equal to true. So first let's take a fresh list, that is L2 equal to kiwi, apple, guava, strawberry and banana. Now I want to sort it into descending order. So directly, as you can see, we got this from the two steps, that is sorting and reverse, right? So directly here I got raspberry, kiwi, guava, banana and apple. So in this way, it will sort the elements into ascending and descending order. And then here we have a L3. In this L3, I have capital letters, small letters also. So what happens here is when I try to sort the elements, it will sort first the capital letters and then it will sort the small letters. If you see in ASCII values also, the capital A is 65 and capital D is like 68 and small letter A is like 97. So in that first, in that way it will print it. The capital letters are A, D. So it will print the capital letters first in alphabetical order, ascending order, and then it will print the small letters in ascending order, that is the alphabetical order. So first capital letters and then small letters or uppercase and then lowercase. In this way you can sort the elements. So that's it for today, guys. Today we have learned about list and list functions. So today in the data types we have learned about the list category data type, which is list. And inside of that list, we have learned about predefined functions, the functions which you can use to perform operations on any list. Tomorrow, we will learn about inner lists and also about the copy processes in a list and tuple, and also we'll learn about tuple also. So that's it for today. If you have any questions, please feel free to put it in the chat box. And if you like our videos, please subscribe to our channel and also hit the like button. And we have the playlist Python for AI to 2026 in our playlists in our channel. And you can watch all the videos from day one to till this day in there. So all the videos will be saved there. So you can use that and you can learn all the data types and revise it. So that's it for today, guys. Please stay and fill the feedback form.